Hello. So, I welcome you to the fourth week session of the mathematical method course. So, this will be about the fourth week assignment and the fourth week lectures which you have gone through in the last week. So, uh, this is the today's agenda. So, first I will cover like basic concepts which you have learned in your week 4 course. So what you learned? So first you learned about the partial differential equations. So uh, first you in the first two lectures of the week 4 you learned about the formation of the partial differential equation by eliminating the arbitrary constants, and then how to form differential partial differential equation by eliminating the arbitrary functions. Then after that you learn like how to solve the how to solve the linear partial differential equations using the Lagrange's equation. And in the last two lectures of the week 4 you learned about how to solve the nonlinear partial differential equations. So in the nonlinear partial differential equations in the week 4 you have learned three types of equations, like three standard rule in order to solve the nonlinear partial differential equation. So let me just start my marker highlighter. Yeah. So here first I will start with the formation of PDE by eliminating the arbitrary constants and arbitrary functions. So for this I will be straightly starting with the problems, so you can let me know if there is any doubt, and please feel free to stop me in between anytime you feel if something is not clear. So here I will directly starting with the questions. So first what I will do, I will take questions like forming partial differential equation by eliminating the arbitrary constants, right? And then we will also see how to solve the PDE by using the arbitrary functions method. So here is the first problem. So you are given a partial differential equation which is z is equal to ax plus by plus a square plus b square, right? And you see there are two constants involving in this equations. So two constants are a and b, and then you have x and y are two independent parameter and z is a dependent parameter. So and now what you need to do, you need to take this equation and from that you need to form a partial differential equation. So looking at the given equation, you can see that it has two constants. So the formation of partial differential equation can be done by simply eliminating the arbitrary constants, right? So let's go through the solution of this. So what you have, you are given with this equation z is equal to ax plus by plus a square plus b square. So the general rule to in order to solve such problem is to basically you eliminate both a and b from this equation, and then you again put them in the given equation, and that will be the partial differential equation. So let's start. So you are given with the equation of this form, z is equal to ax plus by plus a square plus b square, right? Now what you can do, you can ask like what is the partial derivative of z with respect to x, right? So if you see this equation, then the given equation has only one this one function which is of x, right, which has a coefficient of a. So if you just simply take the derivative of this with respect to x, what you will get, so you will get del z del z by del x is equal to a, right? Because there is no other function of x in the given equation, and all others are constant, so their derivative with respect to x will be 0. Now you can again ask like what is the derivative, what is the partial derivative of z with respect to y. So again y has only this function, like which is by, so the derivative of z with respect to y will be just b, right? Now what I told you, what you need to do in order to solve such equation, you now basically eliminate both a and b by simply putting a as a del z by del x and b as del z by del y. So now you just substitute the value of a and b in the given equation. So what you have z is equal to x times del z by del x, because the coefficient of x is a. Simply you have a coefficient of y which is b, so you have y times del z by del y, which is nothing but value of b. And again you can substitute the value of a square and the value of b square. So value of a square will be del z by del x ka whole square, and then value of b will be del z by del y whole square. So this is basically the partial equation that is found by eliminating the arbitrary constants in the given equation. So this is how you solve such type of problem. So I hope you got the flavor, like how you will solve the how you will form the partial differential equation when you are given with such equations. So this is all about the solution of the first question, right? Now what we will do, we will again solving one more problem of the same kind. So again, in question 2 you are given equation which is z is equal to x minus a whole square plus y minus b whole square, right? Now again you see this equation has again two constants. So basically in order to form the partial differential equation, we can use the method of arbitrary constants, where you can eliminate the value of both a and b, and then you will get your partial differential equation. So again let's go through the solution of this problem. So what you have, you are given an equation which is z is equal to x minus a whole square plus y minus b whole square, right? So now what you have del z by del x. Now again you take the partial derivative of z with respect to both x and y, right? Now if you take the partial derivative of z with respect to x, what you will get? You have x minus a whole square, right? So if you take the derivative of this function with respect to x, what you will get? You will get 2 times x minus a, right? As shown here. Similarly, you can ask like what is the partial derivative of z with respect to y. So again, here is a whole square involving the function of y. So you will have 2 times y minus v when you differentiate it with respect to y, right? Now you see you in the given equation you have a function which is x minus a whole square and plus y minus b whole square. So what you can do, simply you can just square these terms, right? If you square these terms, like del z by del x whole square is equal to 4 times x minus a whole square, then you can simply substitute the value of x minus a whole square in this, and that will give you the uh, uh, final partial differential equation. So what you do, you substitute the value of x minus a whole square. So value of x minus a whole square will be del z by del x whole square upon 4, right? So what you have del z by del x whole square plus del z by del y whole square. I have simply just squared these both terms and I have simply added them. So what you will get 4 times x minus a whole square plus 4 times y minus b whole square if I just simply square them and add them, right? So now you can take the 4 common in both of these terms. So what you will get del z by del x whole square plus del z by del y whole square is equal to 4 times x minus a whole square plus y minus b whole square. Now x minus a whole square plus y minus b whole square is nothing but z. So basically the final partial differential equation is del z by del x whole square plus del z by del y whole square is equal to 4z. So again here we just use the simply the method of elimination in order to in order to form the partial differential equation. So this is again a problem of second kind which I show like how you can solve this by just simply eliminating the a and b from the given equation. So I hope you got the idea, and you can now solve the questions which are given in the assignment also, and you will see that now these will become more easy to solve. So now we have gone through the method of elimination of arbitrary constants. What we can do now, we can see like how to solve form the partial differential equation by eliminating the arbitrary functions. Okay, so let's start with one more problem which will show you how to do the same when you have some arbitrary function in the given equation. Okay, so here in question 3 what I have shown, I have given one equation which is z is equal to y square plus 2 times some function which is a function of both x and y, right? So you have a function f which is a function of 1 by x plus 1 plus log y, right? So again here you see there are no constants involving in this equation. Okay, so what you need to do now, you need to use the method of elimination of arbitrary functions. What functions? So here the function given is f, right? So what we will do, we will eliminate this function f, and then we will be forming the partial differential equation. So okay, let's go through the solution of this. So what you have this type of equation, which is z is equal to y square plus 2f times 1 by x plus log y, where f is a function of this quantity. Now what you can do, you can again do the same thing which you did in the arbitrary constant method. You can ask like what is the partial derivative of z with respect to x. So now if you see here, the first term doesn't have any function of x, so the derivative of this with respect to x will be 0. But now see, this function is a function of both x and y. So what you need to do, you take the derivative of this function. So you have 2 f dash, where f dash is the derivative of this function f with respect to x, and in the bracket this you will have same quantity. But now as the function f is a function of 1 by x, so derivative of 1 by x will be minus 1 by x square, right? So if you take the derivative of z with respect to x, you will get this quantity, which is 2f dash 1 by x plus log y times minus 1 by x square, right? Now you can simply do the you can again do the same thing by doing the partial derivative with respect to y. So what you have now, if you are taking the partial derivative with respect to y, you have this function. So the partial derivative of z with respect to y will be 2y, right? So you have 2y, and again you take the derivative of this complete function. So what you will have, you have 2f dash times 1 by x plus log y, and again as f is a function of this log y, you need to take the derivative of this as well. So the derivative of log y will be 1 by y, right? So you have the derivative of this z with respect to y as this quantity. Now you see this function f dash 1 by x plus log y is appearing in both of these equation, where you have taken the derivative with respect to x and you have taken the derivative with respect to y. So what you can do, you can simply just eliminate this f dash function from the partial derivative x equation, and you can substitute in this equation, and that will result in the partial differential equation. So if I substitute this value, so you see the 2f dash factor is common in both, right? So I can, so if I just eliminate this, you will have minus x square del z by del x. Now what you can do, you can just simply write the value of this in this equation. So you will have del z by del y plus 2y minus x square del z by del x, which is coming from this equation, times 1 by y, right? Now you see, you can, as you have read, you can simply write del z by del x as p and del z by del y as q, and you will get this type of equation, which is the final partial differential equation of the given equation. So you have yq is equal to 2y square minus x square p. So here I gave you a flavor of how to solve the how to form partial differential equations by eliminating the arbitrary functions, as this equation doesn't involve any arbitrary constant, so you need to use this method in order to form the partial differential equation. Okay, so again I will take one more question, and this is the question which I have taken from the assignment. So you have some phi function, which is phi is a function of s square plus y square plus z square, and then you have z square minus xy is equal to 0, right? So one method to solve such problem is, what you do, you take this as u quantity, like first term which is x square plus y square plus z square as u, and the second term in this function as v. So you have phi is a function of u and v now, and this is equal to 0, right? So now what you can do, you can ask like what is the derivative of this function phi with respect to x, and the fact that both u and v are a function of both x and y. So if you take the derivative of phi with respect to x, what you get, first you write del phi by del u times del u by del x, because u is a function of x, right? Similarly you have del phi by del p del v into del v by del x, because again v is a function of x, right? So now from this you can see, if I find like del u by del x, right? So if I take this equation and I ask like what is del u by del x, right? So what you will get, you will get uh, del u by del x is equal to 2x, which is dependent function. So you will have 2 times z times del z by del x, right? So as del z by del x is equal to p, so you will have del phi by del u times 2x plus 2zp, which is just del u by del x, where I have just substituted the value of del u by del x from this equation because I have taken the derivative of u with respect to x, right? Now again you can find like what is the value of del v by del x. So again if do the differentiation of this, so I have del v by del x, which is again will be 2 times z times del z by del x, because again z is a dependent parameter. And here what you will have, if you differentiate it with respect to x, you will get minus 2y. So here right, we y. So here I have taken the derivative of this with respect to x, but you can do the same thing by taking the derivative with respect to y. So if I again take the derivative with respect to y, I will get this equation, right? Because both u and v are again a function of y as well. So you will have del phi by del u times del u by del y plus del phi by del v times del v by del y, right? And again you need to find like what are the value of del u by del y and del v by del y. So if I again calculate like what is the value of del u by del y, I again go to this equation and I again take the derivative. So del u by del y of this equation will be derivative of x square with respect to y will be 0. The derivative of y square with respect to y will be 2y, right? So you have 2y here. And here the value of derivative of z square with respect to y will be 2 times z times del z by del y. And as you know, the del z by del y can be written as q. So you have 2y plus 2zq, right? And similarly you can do like what is the value of del b by del y. So again let's take the derivative of v with respect to y. So you if you take the derivative of 2xy with respect to y, you will get minus 2x. So you see, if I solve this equation, I get this quantity. Now you can see the functions del phi by del u and del phi by del v are common in both. So what you can do, you can simply just take the ratio of both of these quantity. So if I just take the ratio of both of these equation, so this equation and this equation, I can simply cancel the del phi by del u and del phi by del v terms because they appeared in both numerator and denominator. And if I do that, I can my equation result in this type of function. So you have x plus zp, which is coming from this, and because you are taking the ratio, so x plus zp will be multiplied by this function, right, to zq minus x. And here on the right hand side it will be the combination of these two, this type of partial differential equation. So you have for the given equation, given function, the partial differential equation will be zp minus zq is equal to y minus x. So again I hope like you got the idea like how to form the partial differential equation by yeah, by using the method of arbitrary constant or by using the method of arbitrary function. So here I tried to cover the 4 problems where I have shown how to form the partial differential equation by using the 2 methods, which is arbitrary constant as well as the arbitrary function. So this all you learned in the first lecture of your week 4 lectures. So again now we will going to, we will go starting with the second thing, where now you have formed just the partial differential equations, but now we will in the next slide what we will do, we will be trying to solve those partial differential equation by using the Lagrange's equation. And this is what you covered in your second lecture of the week 4 assignment, right? So here we will be solving the partial differential equation by the Lagrange's equation. So what I will do in this, I will show you like what are the rules of solving these linear partial differential equation by using the Lagrange's equation, and then we will be solving 2 or 3 problems on the same. So here are the working rule for solving the Lagrange's equation. So first of all, this method is only applicable to the linear partial differential equation where the partial derivatives have a order of 1, right? So if they have more than 1 order, then those will be uh, uh, nonlinear partial differential equation. So here what you are given like in future, like what you will be given, you will be given some partial differential equation which will be of this kind. So you will have some q which is again function of x and y, and then again you have a partial derivative of z with respect to y, and right hand question you first write the auxiliary equations of the given equation. So auxiliary equations are also called subsidiary equation. So what you do, you simply write these type of equations. So what you do, you write dx by p is equal to, you can simply write this equation. Now what you can do, you can simply club, like this is a set of three equation, right? Either you can club first two, either you can club second and three, or either you can club first and three. So what you need to do, method of Lagrange multiplier, or by using the method of grouping, and from there you can write the solution of the partial differential equation as a function of u and v is equal to 0, and u and v are nothing but are the value of constants in the uh, value of constants when you solve the these equation by grouping. So here this is the basic methods of solving the partial differential equation, linear partial differential equation using Lagrange's equation, and this will become more clear when I will solve the examples of this. So okay, let's start with the example. So this is the fifth question in this for this week. So what you are given, you are given the first order linear partial differential equation, right? So you have y squared z times p plus x squared z times q is equal to y square x, right? So as I told you, if you compare this equation pp plus qq is equal to r, you can see like the value of capital P will be y square z. The value of to do, you need to write it as this. So dx by p is equal to dy by q is equal to dz by r. So if I now write this, so I have value of p is equal to y square z. So I have dx upon y square z, right? And now the value of like capital Q will be x square z. So I have dy is equal to dy upon x square z, right? And the value of r is y square x. So you have dz upon y square x. Now what I told you, you need to group the function. So either you can group 1 and 2, 1 and 3, and 2 and 3 depending on the simplicity. So here what I have done, so if you see the first and second term, so this has three terms, one which I am referring to this, second term is I am referring to this, and third term I am referring to this. So if you see, if I club the first and second term, I see that zz term is cancelling out, and I can simply solve this equation by simply adjusting the variable, right? So if I take the function from 1 and 2, so if I have dx upon y square z is equal to dy upon x square z, right? So z and z on both left hand side and right hand side get cancels, and what I am left with, I can simply take this x square on the left hand side, and y square can be bring on the right hand side. So I have x of x square dx will be x cube by 3, and simply the integration of y square will be y cube by 3, and you will have some arbitrary constants, right? So I can simply write this as x cube minus y cube is equal to c1. So this is nothing but our function u. So I have found one of the solution of this. Now let's see what we get when we group other terms. So again, if you see, like if I club 1 and 3, right? So 1 and 3 are function of y and z, and here you have a function of y and x. But if I group 1 and 3, right, uh, what I get, I will get I will cancel both y.
Sir,
Yes, yes, tell.
sir,
Yes,
yes, and form from 1 and 2 forming x cube minus y cube equal to c1,
right.
but to form 1 and 3,
Yeah.
x square minus z square ka sir, but y square
Oh
minus
yeah, so thank you for the, I will yeah, thank you, it should be z square, right? Thank you for the correction, right?
yes sir.
Okay, thank you. Yeah. So here, as you mentioned, this is a typo error because I have written all of these equation in LaTeX from myself. So what you will get if you club 1 and 3, you will cancel the y square on both sides, right? So you will get x dx is equal to z dz, and you will get x square minus z square is equal to c2. So yeah, thank you for this. Yeah. So hence the desired solution will be f is equal f u v. So u is x cube minus y cube, and v will be x square minus y square is equal to x square minus z square is equal to 0. So thanks for noting the mistake. There is a type of like linear partial differential equation by using the Lagrange's method. So in this problem, you see it was very easy to separate the variables by eliminating the function z or eliminating the function of y. But in some problem what you will get, it's not easy to separate the variables, and that we will be seeing in the next question. Okay, so here you are given the equation of this type. So again, if you compare it with the our general equation, so value of it in the form of dx by p is equal to dy by q is equal to dz by r. So here I have written in this form. So you have p is equal to x times y minus z, q is equal to y times z minus x, r is equal to z times x minus y. So you have dx upon p, dy upon q, and dz upon r. So here you see it's not very easy as compared to before problem in order to separate the variables. So what we do here, we use the another method which is called Lagrange's multiplier. So what you do in this equation, in such type of problem, you write it in this form. So you write in the numerator like lambda times dx plus mu times dy plus delta times dz, where lambda, mu, and delta are some constants. And then in the denominator, what you write? U times lambda times p, where p is x times y minus z. You write mu times q, where q is nothing but y times z minus x. And then you will have delta times zx minus y, right? Now, what you do in this equation, for some particular value of lambda, mu, and delta, you try to make the denominator is equal to 0, and then you put those values in the of lambda, mu, and delta in numerator, and then you solve the value of u and v, and then you form the partial differential equation. So let's take the first case. So if I take the value of lambda, mu, and delta is equal to 1 1 1, like all three values are 1. So you see, you completely eliminate the denominator, because y minus z and z minus x and x minus y, these all factors will cancel out, because first term, if first term has positive terms, then second and third term will have the negative sign of that. So you completely eliminate the denominator if you choose the ratio of lambda, mu, delta as 1 1 1, right? And as I told you, what you do now, you substitute these values of lambda, mu, and delta in the numerator. So if I substitute the value of lambda, mu, and delta in the numerator, I have dx plus dy plus dz is equal to 0, right? Okay, so now I can just simply integrate on both the side. If I just simply integrate, what I have integration of dx is x, integration of dy will be y, and integration of dz will be z. So I get one constant which is x plus y plus z, which is nothing but function u. Okay, now I again need to solve another function v in order to get the final solution. So again, if you see here, if I again take the value like of lambda, mu, and delta as completely eliminate the denominator, right? And again the like denominator will become 0. So again you put these value in the numerator. So what you have, lambda, value of lambda is 1 by x, so you will have dx by x, then you have d by y by, because the value of mu is 1 by y, and then you have the value of dz times z, right, is equal to 0. And from here you can again do the integration on both sides, and you know, like the integration of dx by x will be ln x plus ln y plus ln z, and you can write these sum of ln x plus ln y plus ln z as a product. So what you have, you simply have x y z is equal to some constant c2, which is nothing but function v. So the final solution of this differential equation will be f times x plus y plus z, and xyz is equal to 0. So this is how you solve such type of problem. Like in the assignment also, you will see like there are many problems which involve such type of functions, where you need to, where it's not easy to completely separate the functions as we have seen in the earlier problem, and you need to use this method of Lagrange's multiplier in order to solve such partial differential equation. And so here what I did, I again gave you some flavor of how to solve the first order partial differential equation by using the Lagrange's equation. And I hope it's actually very easy. You just need to write the subsidiary equation, and then you just use the method of Lagrange multiplier if they are not separable, or if they are directly separable, then it's very easy to form the partial differential equation. Okay, so this is all about the solving the partial differential equation using the Lagrange's multiplier. And I will urge you to, if you have not tried the assignment problem, you can again try them and you will find them easy. You just need to use this method in order to solve them. Okay, now we will be starting with the last sets of problem, which is like the lecture 4 and 5 of your week 4 lectures, right? So what you learned in there? So earlier you learned, like, if you have a power of, like, order of partial derivative, like del z by del x of order 1, then you can solve them by just Lagrange's equation, because these are linear partial differential equation. But what you do when you have a nonlinear PDEs, when you have a higher order terms that is coming into the partial derivative. So this is what you learned in the week 4 last lectures. So what you learned there, you learned three types of standard form of the partial differential equation, and for all those three standard form there is some general method which you need to follow in order to solve the partial differential equation, right? So here what I will do, I will be first specifying the first three standard forms, like what steps you need to follow in order to solve those equation. And then you will see in the week 5 you will have more of the standard form. So here you just covered the three standard form, but later in the week 5 you will have more standard form in order to solve the PDEs. Okay, so here what I will do, I will just start with the first type of form. So here what you will given, you will be given some equation which will only contain p and q, but it will not contain any function of x, y, and z. So this is what I am calling the standard form 1. So standard form 1 is, just to recall, standard form 1 is when you just have a p and q in your equation and there is no term which is involving x, y, and z. So what you can write, you will have such type of function. You will have f function, some function p and q is equal to 0, because it's not a function of x, y, z, right? So now the complete solution you need to follow in order to solve the problem which are of this type. So now if you take the derivative of this equation with respect to x, what you will get, p is equal to a, and similarly you, if you take the derivative of this with respect to y, you will get q is equal to p, right? Now what you can do, you can simply write this p and q function, because now the p and q are can be expressed in terms of these constants. You can simply eliminate the values of both p and q from these terms, and you can put this in the given differential equation, given equation. So if you put the value of p and q from here in the given equation, you will have a term which is f a b is equal to 0, right? Now from there what you can do, you will have a equation which is just involving the constants a and b. From there you can simply eliminate one constant, right? So you can write either b in terms of a, or either you can write a in terms of b. And if you write b in terms of a, you can simply express b here as a function of a, and this will be your complete solution of this equation. So this is the general method to solve the differential equation when you have a just function which contain just p and q and not x, y, and z. So here I will take one problem where I will be showing you the same steps which I shown here in order to solve such problem. Okay, so you are given this problem, so you need to solve this PDE. You need to find the solution of this, where you are given PQ plus P plus Q is equal to 0. As you see, this equation only involve function which are PQ or P or Q, right? And this is a nonlinear differential equation. So what you need to do, you again need to follow this step. So what I told you, first you write this FPQ is equal to 0, right? And as you know, the solution of such type of problem is z is equal to ax plus by plus c. So what you need to do, you just simply replace the value of p by a, and the value of q is simply replaced by the b, and then you find the one of the constant in terms of the other constant. So here let's do this. So as I told you, you replace value of p by a and value of q replaced by v. So if I put value of p and q as a and b in the given equation, so substitute just p is equal to a, q is equal to b. So you will have ab plus a plus b is equal to 0, right? So again I have written here, and as I told you, now you, what you do, you eliminate one of the constants. So what I can do, I can take a common here, so a plus, now as I told you, you can eliminate the constant b. So b can be written as minus a upon a plus 1, and that value of b can be written in this equation where this is the general solution of such type of partial differential equation. So what you will have, you have z is equal to ax plus b, because now b is a function of a, right? So I can write it as function of a, plus y plus c1, right? So now the value of b can be minus a upon a plus 1. So z is equal to ax minus a upon a plus 1 times y plus c is equal to 0. So this is a like you see, it's a very easy problem. Like if you get like a problem which just involve p and q, you just follow these steps and you will get the solution of such type of partial differential equation. And I hope you got the idea, and you can follow just these steps in order to solve the partial differential equation which are of this type, where you have only function of p and q but no function of x, y, z. So this is the first standard form which you have covered during your lecture, and I tried to give you one example of the same. Now what we do, we will again starting with the uh, second type of problem. So the second standard form of such type of nonlinear partial differential equation will be where you have the function p, q and z, where but there will be no function of x and y. So this I am calling the second standard form. So first standard form was when you have just function of p and q but no x, y or z, right? But second standard form is when you have function of p, q and z but no x and y, right? So again you can write the function equation. So the given equation will be of this form. You have some function p, q, z is equal to 0. Now one of the very easy way to solve such problem is you can assume the solution of such type of partial differential equation and y to u. So you can write u is equal to x plus ay, right? So now if you take the derivative of this function z with respect to x, right? So you know now x is not appearing directly, but it's function of u, because u is a function of x and y. So what you need to write, if you take the partial derivative of z with respect to x, you need to write del z by del u times del u by del x, because here the u is a function of x, right? Now if you try to calculate like what is del u by del x, like if you differentiate like what is del u by del x, you will get only 1, right? Because the coefficient of x is 1. So the value of small p will be del z by del u, right? So this is what you get when you just differentiate this equation. Now you can again ask like what is the value of q. So q is del z by del y. So again you take the difference, express this partial derivative in terms of u. So you have del z by del u times del u by del y. Now the if you take the derivative of this u with respect to y, you will get only a, because the coefficient of y is a. So simply the q can be written as a times del z by del u, right? So you see now you have simply expressed the both value of p and q in terms of one function only, which is del z by del u, right? And if you what you can do, you can simply substitute these value of p and q in the given equation, partial differential equation, and you will see that these the resultant equation can be simply solved by separation of variable method, right? So this is how you solve the second standard type of equation when you have a function p, q and z, right? So again I will be going through the solution of this, one of the examples where I will show you how to solve such problem. So you have z is equal to p square plus q square, and you see now this function has both p, q and z. So you will call it as a nonlinear partial differential equation of the second standard form, right? So what you do first, you change the variable. So you write u is equal to x plus ay as I told you, and then you calculate like what is the value of p, right? So the value of p is del z by del x, right? So del z by del x can be expressed as del z by del u times del u by del x, and you will have p is equal to del z by del u. And again the value of q can be written as a times del z by del u, as I have shown you before. And now what you do, you take these value of p and q and substitute in the given equation. So given equation is z is equal to p square plus q square, right? So I can just simply substitute the value of p and q here. So the value of p will be del z by del u whole square, and the value of q will be a square times a times del z by del u whole square, because the value of q is a times del z by del u, right? So what you can do, you can simply take the del z by del u common. So z will be 1 by a times whole square times del z by del u whole square, because it's the whole square which is appearing, and if I take a out of this square, you will get a square. So it will be 1 plus a whole square uh, times del z, oh, there is one more mistake I realize. So this should be just 1 plus a square, not 1 plus a ka whole square, right? Uh, okay, I hope you got the mistake. So there should be 1 plus a square, not 1 plus a ka whole square, right? Okay. So now what you can do, you can simply do the square on both sides, right? So here I have corrected my mistake, but again here just to show you what you can do, you can simply write this as du you can take on the left hand side, right? And z you can bring here, because as I told you, if you do such method where you change the variable, you will get a equation which you can solve by simply changing the variable. So what you need to do, you have du is equal to 1 plus a square का square root, because here it's a square, right? Because del z by del u whole square, you can simply do the square root on both sides, right? So you will get du is equal to 1 plus a square. Again here is a typo, right? So 1 plus a square square root upon 1 plus z power half times dz, right? I hope it's clear, it's easy. I have just make some error here in writing the square, but I hope you got the idea. So here if you see, the resultant equation is written in such a form that it can be easily integrable, right? Because the variables are already separate. So what I can do, I can just simply do the integration on both sides. So what you will have, you will have u plus b, right? Because the integration of u will be some u plus some constant b, plus plus if you now do the integration of 1 by z square root dz, you will get 2 times 1 plus a square, where now I have written this correct. So you have 1 plus a square square root times z plus half, right? So the resultant equation will be x plus ay plus b, where I have simply replace again u by x plus ay, right? So if you write u is equal to x plus ay, so you will have x plus ay plus b, and again you can do the square on both sides to eliminate these square roots. So you will have 4 1 plus a square times z. So this is the final solution of such type of partial differential equation. So I apologize you for this error. I will, when I will upload these slides, I will correct this. Okay. So I hope you got the idea, like how to solve such type of equations when you are given the second standard form, which is where you have three functions, where you have p, q, and function of c, right? And no x and y. So again, you will see many problem in the assignment which are of these types, and those can be same simply by doing such method. Okay, you just follow the step and you will be able to solve the question. Now, the last type of standard form which you have learned in your week 4 lectures is this. So you will have you will be given some equation which will now will have four terms, which is x, y, p, and q, but not z. Okay. So again to recall, so first standard form is where you have just p and q, no x, y, z, right? Second standard form is where you have p, q, and z, but not x and y, right? So the third standard form is where you have both x, p, q, and y. Okay, so this is the third standard form. So one of the, like a very easy method, this type of, so equations are actually very easy. What you need to do, first you simply express the variable. Like if you have some term like x and p, so you bring the x and p terms on left hand side, and simply if you have some term y and q, you simply bring them on right hand side, and you just write in it in this form. So you will write some function of x and p on left hand side, and some function of y and q on the right hand side. Now what you do, you simply call them some constant a. So here f1 xp is equal to f2 yq is equal to some constant a, right? Now from here what you can do, you can simply eliminate the function p in terms of a and x, right? So here if I solve just f1 xp is equal to a, I can write the function p as some function of x, right? Because small f1 is a function of x. Similarly, I can express q as some function of y using this equation, right? Now you know that dz can be written as del z by del x times dx plus del z by del y times dy. and you know like this is p and this is q, so you simply just write this value of p is equal to f1x here, f1x times dx, and simply you write the value of q is equal to f2y times dy here. And you see this is a like a very easy equation in order to solve it, because this equation in this equation the variable are already separated, so it's very easy to integrate this equation. So this is how you solve such type of particular equation which are given in the third standard form. And I think like such type of problems are very easy, because you just need to first separate the variables involving x and p and y and q, and just you simply put them to some constant, and then they are easily solvable. So here this is the theory which you learned in the week week 4 lectures, all of it. So what I will do, I will try to solve two problems which will be involving the third type of standard form. Okay, so you are given this type of equation. So you have yp is equal to 2xy plus log q, right? So here you see it's a function of both x, y, p and q. So what you will call it? You will call it as the third standard form, right? So what you do in the third standard form, first you write the functions which involving p and x and q and y on left hand side and right hand side, right? Okay, so what you have, p is equal to 2x plus 1 by y log q, right? So as I told you, you can simply divide this equation by y on both sides, so you will have p is equal to 2x plus log q upon y, right? And what you need to do, so as I told you, what you need to do, you need to equate it to some constant which is a, right? So if I do that, what I will get p minus 2x is equal to a, and similarly I will get 1 by y times log q is equal to a, right? And from here, as I told you, what you need to do, you simply write the function p in terms of x. So the function p in terms of x will be a plus 2x, and similarly so the function q in terms of y will be exponential power ay, because you what you can do, you can write log q is equal to ay, and then you can simply take the exponential on both sides, so you will have q is equal to e times ay, right? And as I told you, what you need to do, you need to write dz by del z by del x times dx plus del z by del y times dy, and you simply substitute this value of p, which is nothing but del z by del x, and similarly you substitute the value of q, which is nothing but del z by del y here. So you have d dz is equal to a plus x times dx, which is coming from here. So again there is one mistake, so it should be 2x, a plus 2x, right? Because you have p is equal to a plus 2x, so you have a plus 2x times dx, and similarly you have del z by del y, which is e a power I times dy. So just to again mention, here you will have some factor of 2, a plus 2x, because your p is a plus 2x. Now what you need to do, you can just simply do the integration on both sides, right? So if you do the integration of dz, you will get z. Similarly the integration of a dx will be ax, and then you have 2x dx integration will be x square, because 2 and 2 will get cancelled, right? So you will left with just x square. And similarly the integration of e power ay will be e power ay upon a, and you have some constant. So this is the solution of such type of partial differential equation which are of this form, which is nothing but the third form, which is the variable separable form. Okay, so I hope you got the idea like how to solve such problem, and again you can find such type of problem in the assignment, and you can solve them, and you will feel like it's very easy if you do them by this method. Okay, now I will start with the last problem of this week assignment. So what you have again, you have some equation which is root p plus root q is equal to x plus y, right? So again you see you have four functions here, p q x y, right? So you again, what you will call it, you will again call it the third standard form, right? So what you do in the third standard form, you can bring this variable on left hand, bring this function x on left hand side and to a, which I am calling some constant. And what I write now, root p minus x is equal to a, and similarly y minus root q is equal to a, right? So what I can write from here, I can simply write a plus x is equal to root p, right? Because I can bring this x on the right hand side. And from there, what you can write, you can write p is equal to a plus x whole square, right? because I can square them on both sides. So you will have del z by del x is equal to a plus x whole square. Similarly, you will have q is equal to y minus a whole square, right? Because q is nothing but del z by del y. Now you again put them in this equation. So you have dz is equal to p times dx plus q times dy. So p is nothing but a plus x whole square, and q is nothing but y minus a whole square, right? And now you see it's very easy to integrate this problem because it's already a variable separable form. So what you will have if you do the integration on both sides, you will get 3z is equal to a plus x whole cube plus y minus a whole cube plus b, right? So this is the final solution of such type of partial differential equation. Okay, so this is all about the last question, and also this is all about the this week assignment. So I hope I was clear enough to give you a brief recap of what you learned, and I just present you a summary of what methods you learn, and then I showed you some examples which are solved using such methods. Okay, so I hope you got the idea, and sorry, like there was some typo error, but this I will take care of when I will be uploading this on the drive. So I suppose if you have any question you can ask, or we can just call it off for the day. So
Sir,
yes,
sir,
yes, tell.
actually one small doubt, sir.
Yes,
Actually, these questions I understood.
yes,
Hello,
yes, are you able to hear me?
sir.
Hello.
Yeah, sir.
Yes, tell.
These questions. Hello,
Hello.
these questions understood.
Okay.
Hello,
Hello.
sir.
Yes, I am there.
Hello.
Hello.
Okay, sir. These questions understood, sir. But before lectures, sir explained the video and a recorded video, sir. That questions very difficult, sir.
In the assignment you
Not
are saying,
understand.
or in the assignment or
The
the.
assignments also easy.
Okay.
Video lecture, sir.
Okay, so what you like difficult in them? Uh, what is the difficulty in them? Hello?
Three questions, not understand anything.
Oh, like you can let me know and I can
That we
yeah. Can
very difficult, sir. Explained on little difficult. Little
oh,
not understand for me.
like just week 3, right? Hello?